Hello my dear students, today we are going to see our lecture 3 which comes under the unit simple stresses and strain. So today we will see few topics which we have to study in a deep manner. So first we will start with our content. What are the content we have to cover throughout this lecture? So these are our content. First one is tensile stress and tensile strain. Second one, compressive stress and compressive strain. Third one, shear stress and shear strain. Fourth one, modulus of rigidity, which is also known as rigidity modulus. Next one, single shear stress. Next, double shear stress. And finally, we will see what is factor of safety. So, dear students, already we know the basic concept of stress and strain. If I will ask you what is stress, then what you can answer me or what you will answer me? See, the force of resistance per unit area offered by a body against deformation is known as stress. If you will see mathematically, then sigma is equal to P by A, where P is equal to external force or load and A is equal to cross-sectional area and sigma is stress. So already we know the basic concept about stress and strain. In this lecture, we will see what is tensile stress and tensile stress. So first we will start with our content number 1, tensile stress and tensile strain. See the definition. See, one thing I will tell you, I have prepared a simple and easy language for you guys. If you will see, I have prepared definition in a very simple manner, so you can easily mug up or you can easily understand from this PPT. So first we will start what is tensile stress and tensile stress. So tensile stress, when the body is subjected to two equal and opposite axial pulls, that means tensile load, then the stress induced in the body is known as tensile stress, and the corresponding strain is called tensile strain. Understand? Because of tensile stress, the length increases and the cross-sectional area decreases. That is true also. Suppose that this is an object. Understand? This is an object. If you will pull from this side and we will pull from this side also, then what will happen? Its length will increase, na? Maybe it will come after. It will come from here to here, understand? But cross-sectional area will decrease. Its thickness will decrease, na? Only length will increase. In simple manner, I am telling you. So that is called as tensile stress or tensile strain. Because of tensile stress, the length increases and cross-sectional area decreases. Understand? And the very important things which we will always do during solving the problems, that means tensile stresses is denoted by a positive sign. Why positive sign? Because its length is increasing. Understand? Its length is increasing. If its length is increasing, that means positive will come. Understand? And what is tensile strain? Due to tensile stress, the change in length will come. Due to the tensile stress, the change in length will come. That is known as tensile strain. Understand? Now we will see another topic. Compressive stress and compressive strain. Listen, what is the definition says? When the body is subjected to two equal and opposite axial push, one thing you should always remember, in tensile stress, here it was written pull, but in compressive stress, it is written as push. Understand? So, when the body is subjected to two equal and opposite axial push, that means compressive load, then the stress induced in the body is known as compressive stress and the corresponding strain is called compressive strain. Understand? That means before the force was outside the body. That means we were applying force from this side to this side, axial pull, understand? But now we are applying force towards the object, towards the object. We are applying load or force towards the object. That is called as compressive, understand? Compressive is, in simple word, we are compressing something. Compressive stress means suppose that we are compressing something, understand? We are applying compressive load, that is called as compressive stress. See, one more point, because of compressive stress the length decreases and cross sectional area increases. That means suppose that this is a rod. If we are applying load from this side or force from this side, what will happen? From this side the length will decrease, from this side also length will decrease, so it will become only this much length of object, and its thickness, that means its cross sectional area will increase, it will become little thicker, it will be reduced in their length but it will be gained their thickness. That is called as cross sectional area increase, understand? Okay, I will erase these things, understand? Then one more thing, dear students, what is written in third line, third point? Compressive stress is denoted by negative sign. Negative sign, why? Because in compressive stress our length is decreasing and we are applying the force inwards the object, not outwards the object. We are applying our force inwards towards object. See here, understand? So this is compressive stress and corresponding the stress that is known as corresponding compressive strain, understand? We will see in the next topic. Now we will see what is shear stress and what is shear strain. Actually, if you will see the shear stress, it is the stress induced in a body when subjected to two equal and opposite forces which are acting tangentially across the resisting section as shown in figure, understand? As shown here. Tangentially means, suppose that this is a circle. Tangentially means this is tangent, understand? So the force which is acting at tangent is known as tangentially, understand? Tangentially force, understand? Am I clear or not? So as a result of which the body tends to shear off across the section is known as shear stress. The corresponding strain is known as shear strain according to stress, understand? The shear stress is the stress which acts at tangent to the area and it is represented by tau. It is represented by tau and tau is equal to P by A, where P is equal to shear resistance and A is equal to shear area, understand? Now we will see shear strain. This is the diagram, understand? Now we will see the shear strain. So shear strain is denoted by phi. You can write like this also. It is denoted by phi. So phi is equal to dl by h. Now we will see modulus of rigidity, which is also known as rigidity modulus and which is also known as shear modulus, understand? Keep in your mind. Modulus of rigidity is also known as rigidity modulus or it is also known as shear modulus, SHEAR, shear modulus, understand? So its definition says like this: the ratio of shear stress to the corresponding shear strain within the elastic limit is known as modulus of rigidity, or we can say as shear modulus or rigidity modulus. Understand? Then one more thing you have to keep in your mind, that it is denoted by the letter C, G, C, G and N. Understand? So don't get confused. Sometimes in your exam or in your question paper, they will give the value of C. Then you have to consider this one as modulus of rigidity. If they will give the value of G also, or they will give the value of N also, then also you have to consider the value as modulus of rigidity or rigidity modulus or shear modulus. Understand? So its unit is Newton per meter square. If you will see the mathematically modulus of rigidity, it is written as shear stress divided by shear stress. That means tau divided by phi. Understand? Tau divided by phi. So G is equal to, or C is equal to, or N is equal to tau divided by phi, and its unit is Newton per meter square. Now we will see what is single shear stress. Actually, if you will see this diagram and this diagram, consider the section axis of the rivet forming joint between two plates subjected to tensile forces. Understand? Subjected to tensile forces. If you will apply the pressure from this area, or force from this direction and force from that direction, then what will happen? The rivet breaks into two pieces. Understand? The stress developed in the rivet is single shear stress. Actually, the stress which will be developed here due to this force, is what? Single shear stress. Understand? And its unit already, its formula already you know, tau is equal to P by A. If we will see double shear stress, same thing, but here what will happen? Here the rivet breaks into three pieces. Why? The rivet is said to be in double shear stress. क्यों? क्योंकि जो हमारा यहाँ पर रिवेट होगा वो डबल shear स्ट्रेस को क्या करेगा? फील करेगा. So the rivet is said to be in double shear when it is subjected to the forces as shown in figure. जो हमारे फिगर में दिया गया उसके अनुसार the rivet breaks into three pieces. तीन पीस में टूट जाएगा, and the stress developed in the rivet is double shear stress. And here the formula comes like this: tau is equal to P by 2A. Always keep in your mind. In single shear stress, tau is equal to P by A, but in double shear stress, tau is equal to P by 2A. Now we will see our final content, which is factor of safety. What is factor of safety? Actually, it is defined as the ratio of ultimate tensile stress to the working stress, and working stress is also known as permissible stress. Understand? Working stress is also known as permissible stress. So don't get confused. Sometimes in the question paper they may ask, or they may give the value of permissible stress. So you should always know permissible stress is only known as working stress. So if you will see mathematically it is written as ultimate stress divided by permissible stress or working stress. If you will see as a whole, what is factor of safety? As a general idea, a strength of the component divided by load on the component. Understand? A strength of the component divided by load on the component. That is known as factor of safety. And factor of safety is very important. Understand? For each and every material, especially in mechanics of solid. In many numericals, you have to always find factor of safety. Sometimes they will give the value of ultimate stress, and factor of safety they will give, then you have to find permissible stress. Sometimes they will give the value of permissible stress, then ultimate stress, you have to find the factor of safety. So these things you have to always keep in your mind. Understand? Now we will see our summary. Already we have completed all our content such as tensile stress, tensile strength, compressive strain, shear strain, modulus of rigidity, which is also known as rigidity modulus, single shear stress, double shear stress, and finally we have seen factor of safety. So once again we will summarize these things. Okay, what is tensile stress and what is tensile strain? Actually, the stress induced in a body when subjected to two equal and opposite pull. Understand? You have to always keep in your mind, for tensile stress, one pull forces will come. Combination of two equal and opposite pull forces or pull load will come, which will be result in increase in length. That is known as tensile stress. And if you will see compressive stress, then compressive stress means two equal and opposite pushes, not pulls, pushes, understand, which will decrease in length. Actually, if you will see in tensile stress, it helps in increase in length, but if you will see in compressive stress, it helps in decrease in length. Understand? That is known as compressive stress. If you will see shear stress, what is shear stress? When a body is subjected to two equal and opposite forces, we are acting tangentially, that means at tangent, understand, across the resisting section. As a result of which the body tends to shear off, understand, it will get shear off across the section, that is known as shear stress, understand. Then we will see modulus of rigidity, which is also known as shear modulus or rigidity modulus. It is denoted by G, C or M. What is it? The shear stress divided by shear strain is known as modulus of rigidity or rigidity modulus. Or in mathematically we can see that C, G or N is equal to tau divided by phi. Understand? C, G, N is equal to tau divided by phi. It is known as modulus of rigidity or rigidity modulus. And what is single shear stress? In single shear stress, single shear value will available. In double shear stress, double shear will available. And finally, we have seen factor of safety. What is factor of safety? It is the ratio of ultimate stress divided by permissible stress. Understand? Ultimate stress divided by permissible stress. Or we are also know one thing, permissible stress is known as working stress. Understand? Permissible stress is only known as working stress. So these are the topics which we studied throughout this PPT or throughout this lecture. Understand? If you will see the reference, you can get the good knowledge or perfect knowledge about this particular topic from these books. First one is Strength of Material. It is written by Dr. R.K. Bansal and the publisher name is Dhanpat Rai and Sons. The second book you can refer is Mechanics of Solid books from R.S. Khurmi. R.S. Khurmi is good. Actually, he is a good author. If you will solve from these two books, Dr. R.K. Bansal books and R.S. Khurmi big books, then easily you can solve almost all the numerical problem. So I will give you suggestion, you should mostly focus on these two books. Understand? Only two books. If you will follow only two books, then you can get easily all types of knowledge. Understand? So dear students, actually we have learned a lot throughout this lecture about mechanics of solid in lecture 3 from unit simple stresses and strain. Understand? I hope you all must have understand everything in an effective manner. Then you will apply when we will solve numerical problem, because soon I will make video on numerical problem also. So during that time you can compare these theory parts with numerical parts. So why I have given all the notes in a simple and effective manner? Because it will help you to mug up also. Most of the students are from Bihar board also, so you are unable to mug up the big line definition. So I have given all the definition in a simple and effective manner. So only one line definition. So you should always remember this definition and especially all the formulas. Then we will further use in solving numerical problems. Thank you students. My name is Sudhir Kumar. I am the lecturer of James Polytechnic College from Mechanical Department. Thank you.